Wildcat, segment at 1. Can't touch this. Introduction to rational functions. The student works 1, 2, 3, and 4. All right, let's take a look at the next page. Getting started. Two integers, both alike in dignity. You have learned about rational numbers in previous courses, and you have used rational numbers throughout this course. Let's review what you know. 1. List some properties of rational numbers. Rational numbers are the ratio of two integers. Their decimal representations are either terminating or repeating decimals. 2. Determine the reciprocals of the rational numbers you wrote in question 1. Explain why these numbers are reciprocals. The reciprocal of 2/3 is 3 divided by 2. The reciprocal of 1/4 is 4 divided by 1. These numbers are reciprocals because 2/3 times 3 divided by 2 equals 6 divided by 6, which equals 1. And 1 divided by 4 times 4 divided by 1 equals 4 divided by 4, which equals 1. 3. Explain what happens when the denominator of a rational number is 0. When the denominator of a rational number is 0, its value is undefined. A number divided by 0 is equal to undefined. Number 4. Write a definition of rational number. A rational number is any number that can be written as the ratio of two integers, a divided by b, such that b does not equal 0. All right, let's take a look at the next page. Activity 1.1, Graphing Rational Functions. Throughout this course, you have studied many connections between polynomial functions and real numbers. It follows then the polynomial functions also have reciprocals. Is the reciprocal also a polynomial? Is it a function? How does 1 divided by f of x compare to the original function f of x? To begin answering these questions, consider the reciprocals of the basic linear function f of x equals x. The reciprocal can be defined as g of x equals 1 divided by f of x, or simply g of x equals 1 divided by x. Number 1. Consider the graph and table of values for f of x equals x. The domain of f of x is negative infinity to positive infinity. The point -1, -1, and 1, 1 are shown and used to create three intervals for analysis. All right, let's go ahead and complete the table. So g of x is 1 divided by x. So this would be 1 divided by -6, 1 divided by -5, 1 divided by -4, 1 divided by -3, 1 divided by -2, 1 divided by -1. All right. This would be 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 4, 1 divided by 5, 1 divided by 6. All right, let's take a look at this. This would be 1 divided by -1. Now, here we're going to need to use the calculator to do 1 divided by -1/2. So 1 divided by -1 divided by 2 is -2. Okay. Now, 1 divided by -1/10, same thing. We're just going to change this to a 10, is -10. Which, if you see what's happening, this would becomes -100. Now, 1 divided by 0 is undefined. One divided by 100 is 100. 10, 2, which all right. Now to graph 1 divided by x. Let's go ahead and use Desmos. Okay, so I'm going to come over here to Desmos. I'm going to graph 1 divided by x. And really, our best points to look at are, looks like, if we can get to it right there, -1, -1, and 1, 1. So let's graph those points. So 1, 1 is right here. And -1, -1 is right here. I don't know why they graphed this line, but I'm going to go ahead and remove it. Because it kind of makes the graph of 1 divided by x kind of confusing. Now, you'll see here that it has an asymptote at x equals 0. Okay? So it has an asymptote at x equals 0. That means it doesn't cross x equals 0. And you can see here that it curves here and here. So okay, and then there's your graph of g of x equals 1 divided by x. All right. Let's take a look at the next page. Describe the graph of g of x. How is it similar to the graphs of other functions that you studied? How is it different? The graph is similar to a quadratic in the sense that it curves. C. Describe g of x as x approaches infinity and negative infinity. Explain your reasoning in terms of the graph, equation, and the table of values. As x approaches negative infinity, y approaches 0. I can see this in the table because the greater x becomes, the smaller y becomes for all positive values of x. For all negative values of x, the smaller x becomes closer, y approaches 0. D. Describe g of x as x approaches 0 from the left. Explain the output behavior of the function in terms of the equation. The function g of x is decreasing. When I divide by negative numbers that approach 0, this results in output values that approach negative infinity. E. Describe g of x as x approaches 0 from the right. Explain the output behavior of the function in terms of the equation. The function g of x is increasing. When I divide by very small positive numbers that approach 0, this results in very large output values that approach infinity. Let's take a look at the next slide. All right, go ahead and mark off this section. 3. Analyze the key characteristics of g of x equals 1 divided by x. Does the graph ever intersect a horizontal line y equals 0? Explain your reasoning in terms of the graph, table, and equation. No, the graph will never intersect the line y equals 0. I can see this in the graph, and I can tell from the table that x increases, y approaches 0, but never equals 0. B. Does the graph ever intersect the vertical line x equals 0? Explain your reasoning in terms of the graph, table, and equation. No, the graph will never intersect the line x equals 0. I can see this in the graph, and I can tell from the table because as y increases, x approaches 0, but never equals 0. C. Describe the domain and range of g of x. Domain is all real numbers excluding 0. Range is all real numbers excluding 0. All right, let's take a look at the next page. Previously, you have represented the domain and range of functions using words, inequalities, and interval notation. You can also use set notation to represent these characteristics of functions. All right, go ahead and look over the worked example. All right, domain and range of the function g of x equals 1 divided by x. D. Write your answer in question 3, part C, using each notation. Inequality notation. Domain is x less than 0 or x greater than 0. Range is g of x less than 0 or g of x is greater than 0. Interval notation. Domain is negative infinity to 0 or 0 to infinity. Range is from negative infinity to 0 or 0 to infinity. Set notation. Domain is x such that x does not equal 0. Range is y such that y does not equal 0. The function g of x equals 1 divided by x is an example of rational function. A rational function is any function that can be written as a ratio of two polynomials. It can be written in the form f of x equals p of x divided by q of x, where p of x and q of x are polynomial functions, and q of x does not equal 0. You have already seen some specific types of rational functions. Linear, quadratic, cubic, and higher order polynomial functions are types of rational functions. All right, let's take a look at the next page. Recall from your study of exponential functions that a horizontal asymptote is a horizontal line that a function gets closer and closer to in most cases. A graph never intersects a horizontal asymptote, but in some cases it does. In this problem, the function g of x has a horizontal asymptote at y equals 0. Given the horizontal asymptote, the range of the rational function g of x equals 1 divided by x can be expressed verbally all real numbers except for 0 as a compound inequality g of x is greater than 0 or g of x is less than 0. In interval notation, negative infinity to 0 or 0 to infinity. In set notation, g of x such that g of x is unequal 0. The function g of x equals 1 divided by x has a vertical asymptote at x equals 0. A vertical asymptote is a vertical line that a function gets closer and closer to but never intersects. The asymptote does not represent points on the graph. If the function, it represents the output value and the graph approaches. As an asymptote occurs for input values, the result in the denominator of 0. A vertical asymptote is often represented in textbooks and graphing calculators as dashed or solid line. The convention used in this textbook is to represent the asymptote as dashed lines. Given that vertical asymptotes, the domain of the rational function g of x equals 1 divided by x can be expressed verbally all real numbers except for 0 as a compound inequality x greater than 0 or x less than 0. In interval notation, negative infinity to 0 or 0 to infinity. In set notation, x such that x does not equal 0. Analyze each function. Circle the rational functions. B. Explain why the remaining functions are not rational. The function h of x is not a rational function because the square root of x is not a polynomial. The function n of x is not a rational function because of the variable in the exponent. C. Do you think the graphs of all rational functions will have a vertical asymptote? Explain your reasoning. Note, if the rational function does not have a variable in the denominator, there would not be a vertical asymptote. Let's take a look at the next page. Activity 1.2. Modeling a situation with a rational function. Suppose you want to purchase a new laptop with the cost is $2,200. Complete the table to show the amount of time it would take to save $2,200 for different weekly saving amounts. All right, so let's go ahead and complete the table. So we have 2,200 divided by 10. $2,200 divided by 20. $2,200 divided by 50. All right, so go ahead and complete the table. All right, let's go ahead and complete the graph. To use the information in the table to construct the graph of the problem situation. Okay, so let's graph the points. 10, 220, it's right there. 20, 110, it's right here. 40, 55, 50, 44, 100, 22, 211. Let's go and connect the points to form our curve. All right, go ahead and finish up your graph. All right, let's take a look at the next page. 3. Can this problem situation be modeled by a function? Explain your reasoning. Yes, each dollar amount saved corresponds to exactly one number of weeks to reach the goal of 2,200. 4. Write an algebraic equation to model this problem situation. Y equals 2,200 divided by x, where x equals the amount saved per week and y equals the number of weeks to save $2,200. 5. Describe the asymptotic behavior of the graph in this situation. What happens to the graph as x approaches 0? As x approaches 0, y approaches infinity. B. What happens to the graph as x approaches infinity? As x approaches infinity, y approaches 0. Let's take a look at the next page. Talk to talk. Change in range and domain. 1. How does a vertical asymptote affect the domain of a rational function? A vertical asymptote eliminates an x value from the domain of the function. 2. How does a horizontal asymptote affect the range of a rational function? A horizontal asymptote eliminates a y value from the range of the function. All right, let's take a look at the next page. All right, describe why a rational function never crosses its vertical asymptote. A rational function never crosses its vertical asymptote because it is undefined at the x value that lies in the vertical asymptote. The student works 1a, 1b, 1c, 1a, 1b, 1c. The student works 1, 2, and 3. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.